Children, can you tell me the shape of this paper? It's a rectangle. This shape is called rectangle in geometry. Means this geometrical figure, what we see, geometrical figures are broadly classified into two types. So as you said, this is the shape of what? Rectangle. So this is a geometrical figure. So this side, what do you call this side? Length. What do you call this side? Breadth. Means it has how many dimensions? Two dimensions. So we call this as plane figure. See, plane figure. So plane figures. Now suppose if you take this solid now. See this. What is the shape of this front face? Rectangle. Similarly, see, means it has more than one face. Means this kind of geometrical figures are called as solid figures. Solid figures. So, into how many types geometrical figures are classified? Geometrical figures are classified into two types. Which are the two types? Plane figures, solid figures. As I said, see, this is an example for a plane figure. So this side you said what? Length. This side you said what? Breadth. So it has two dimensions. All plane figures has two dimensions. So two-dimensional figures, we can say that all plane figures are two-dimensional. Whereas when you talk about the solid figure, see, as you said, this side, this is in the shape of what? Rectangle. This will be called as what? Length. And this will be called as what? Breadth. And this is called as height. So how many dimensions it has? 3 dimensions. So solid figures are of 3 dimensions. 3 dimensions. Okay. Then the second difference that you can notice between a plane figure and a solid figure is, see, here this shape of a paper here you said rectangle, and this is called length and this is called breadth. How to find the area of this? We know the formula. We have studied in our lower class. Tell me, what is the formula to find area of a rectangle? Length into breadth. Means I can calculate area of this plane figure. Whereas, suppose if I take this solid figure, so you said this is in the shape of what? Rectangle. How many faces it has? This 4 lateral faces we say, and these 2 side faces. These 4 lateral faces are in the shape of rectangles. Means if I want to find the area of this front face, L into B. Similarly, this face L into B, this face L into B means it has more than one area. In such a case, we say the solid has a surface area. So the second difference that you can notice here is has only areas. Has only area. Whereas the solid figures has what? Has surface area. So try to make out the difference between areas and surface area. Area means 1. As I said, this rectangle has only area. Length into breadth. Only one area this geometrical figure has. That's why I written as only area. Whereas, see, this solid has more than one area. More than one area. Have you understood? When it has more than one area, we call it as surface area. So that's the second difference that you can notice between a plane figures and a solid figures. And the third one is very important one. We say no volume in plane figures. Let me make it clear what is meant by volume. For example, you see this box, if I take this box, has an empty space inside so that something can be filled inside this box. Means the empty space inside the solid filled by air is called as volume. This kind of empty space we cannot find in case of what? In case of plane figure. Means why we cannot find? Because there is no thickness. There is no thickness. That is why we say plane figures will not have any volume. Whereas the solid figures has volume. So these are the differences that we can notice between a plane figure and a solid figures. The best examples that we can give here is, see, triangles. All kind of triangles, they are plane figures. They have areas. What is the formula to find area of a triangle? Half into base into it, different or equilateral triangle. Quadrilaterals, see, quadrilaterals. All kind of quadrilaterals are plane figures. Another one, plane figure which is most familiar to you, already you have studied, no? Circle, yes. See, circle is the best example. It has no thickness. So for that also we can find area. What is the formula to find area of a circle? Pi r square. Okay. Similarly, when you go for the solid figure, the first example that you can give is the cuboid. Second, tell me you have studied, no? In your earlier classes? Cube. So these are the two solids that you have studied in your previous class. We have seen how to find the surface area of a cuboid and also the surface area of a cube. And in 9th standard, we are going to study how to find the surface area of a cylinder and also how to find the surface area of a cone and how to find the surface area of a sphere. See, these are the another 3 solids which is going to be added this year. So now how to find, now our topic is, so we are choosing this one now. What is this called? Surface area. As I explained, what do you mean by surface area?
More than one.
More than one area. Very good. So if you have more than one area, then it is called as surface area. And then what about this? Volume. What I said for volume? The empty space inside the solid filled by air. You might have seen the Pepsi can, which will be sold in the shop. It contains a label like this, 250 ml. It is in the shape of, tell me what is the shape of the Pepsi can? Cylinder. What do you mean by the written on the top of the can 250 ml? Means it has a Pepsi juice of 250 ml. See, it holds 250 ml of Pepsi juice inside that can. Means that space availability is called as volume. It's called as volume. So we are going to study how to find the surface areas of these solids, how to find the volume of these solids in 9th standard. That is why our chapter plays an important role in 9th standard. What is that? These two I am going to take. Which are the 2 things we are going to select from the solid figures? Surface areas and volumes. So that is our topic now. So today we are going to study more about the surface areas and volumes. Okay. So now
that electrons revolve a box of chocolates. How much paper will you need? How much paint will you need to paint the walls of a doghouse pink? Knowledge of surface area will help Rahul and Priya figure out how much paper and paint they will need respectively. Let's learn more about surface area of cuboids and cubes through this animation. When we talk of surface area, we can be more specific by using the terms total surface area or lateral surface area. Total surface area is the area of all the faces that make up a three-dimensional shape, unless otherwise mentioned. Surface area means total surface area. Lateral surface area is the area of all the lateral faces of a three-dimensional figure. This three-dimensional figure is called a cuboid. How many faces do you think it has? Let's check. You can see that the cuboid has 6 faces. Perhaps you understand this better if you look at the Venn diagram of the cuboid. Can you identify the shape of each face of the three-dimensional figure? Yes, each face is a rectangle. So, if you were to find out the total surface area of the cuboid, you will need to add the areas of all the rectangles. Let's now calculate the areas of each of these rectangles. Do you notice that the areas of rectangles 1 and 3 are the same? The area of each of these rectangles is h into L. Similarly, the areas of rectangles 2 and 4 are the same. The area of each of these rectangles is b into h. The areas of rectangles 5 and 6 are also the same. The area of each.
So see here, once again, the same what has been explained there. I will give you the demo of this. See, this is the face 1 what I have written here. Like that, this 1, 2, the back 3 and the top 4. These 4 faces are called as lateral faces. When you include the top and if I hold like this is vertical position. This is also a cuboid. If I hold like this is an horizontal position. This is also called as a cuboid. The best example for cuboid we can understand the match box what we use at our house. So that's the best example for cuboid. If I hold this what has been shown in the video, this is called a cuboid. See this front face, the back 2, the side 3 and 4. These 4 faces are called lateral faces. Okay, it has a flat smooth surface and this is called as length and this is called as height. So if I want to find the area of this rectangular face, what is the formula? L into H. Likewise you will get 1, 2, 3, 4. So all the 4 faces. If I find the area of the 4 faces, it is called lateral surface area. When I include the top and the bottom, then it is called as total surface area. So now you see this front, back and these 2 side faces. See this front and the back, they are having the same shape, whereas the 2 and 4 are having the same shape. So the formula used to find the area of rectangle is length into breadth, but here length and the breadth becomes the height, so 2 dimensions here. So to find the total surface area of this cuboid, we have to add area of all these rectangles. So now how those areas are added
Rectangles is L into B. On simplifying the expression, we get the following formula for the total surface area of a cuboid.
See, 2 h into L one time, h into L one time, h into L one time, h into L one time. How many times h into L? 2 times. So 2 times h into L. Similarly, b into h we have twice. So 2 times b into h. Whereas the another one which is that L into b. See, you have 2 times there. These 2 faces. So now all of the areas are of 2 times here. So now I have taken 2 as a common factor in the last cell. See here, when you take out the bracket by multiplying the term outside with the term inside, this is the conclusion and this is the formula. What is that formula? Come on, read all of you. 2 times h into L plus b into h plus L into b. What does L represent? Length. What does b represent? And what does height h represents? Height. So if I know the L, B, h of a cuboid, by applying this formula, you can calculate the total surface area of a cuboid. Now let us go for the cube now.
To find the maximum surface area of a cuboid, we need to add all the areas of the rectangles that form the natural faces of the cuboid. In other other words, we have the areas of rectangles 1, 2, 3, and 4. On substituting the values and simplifying further, we get the formula for the natural surface area of a cuboid.
So what is the difference between the lateral surface area and total surface area? Tell me now. Lateral surface area means
You have to take the area of 4 sides.
only 4 sides. When I ask you about total surface area, you should add top and bottom. Here we are talking about what? Lateral surface. That's why we are considering only the 4 faces. So as usual, once again L into B. When you simplify here, area of rectangle, this is L, this is H, L into H. This is also B into H. This is L into H, and that is B into H. So now simplifying, 2 times H into L is there. So 2 times B into H is there. When you simplify, you will get 2 times H into L plus B. Once again, H represents the height, L represents the length, and B represents the breadth. So this is the formula used to find the lateral surface area of a cuboid. Suppose when we come across some cuboids where the top will be kept open. Try to understand my point here. We come across in our daily situations where we find some shapes which are in the shape of cuboid. There will be a bottom covered and the top kept open. Here we have read the lateral surface area and the total surface area. If you have been asked to find lateral surface area, a ready formula is there, that is 2 times H into L plus B. To find the total surface area also, just now we have derived, we have a formula 2 into LB plus BH plus HL. As I said, if the top is kept open, we do not have a ready formula. Then we should use your application skill. What should be done? So, what you should do, you should find the lateral surface area, means the whole area of the 4 faces. The top has been kept open. Then what you should do, you should add the area of the base. Like that. For example, you imagine this room. This is in the shape of a cuboid. We don't want to paint the floor because it is having the tiles. But a painter should paint all the 4 walls and the ceiling. So then what I should do? I should find the area to be painted by calculating the CSA, LSA, lateral surface area, plus area of the top, I mean ceiling. What is the shape of the ceiling? Rectangle. What is the formula to find area of rectangle? L into B. So along with the 4 faces, that is 2H into L plus B, lateral surface area. If you add the area of the ceiling, you will get the area to be painted. Tell me, any questions? Okay.
In a cuboid, the length, breadth, and height are unequal. Now if we make the length, breadth, and height equal, we get a 3-dimensional figure called cube. On opening up the cube, we get a 2-dimensional figure that has 6 faces. Each face is a square as its length and breadth are the same. So the area of one face is a square. To find the total surface area of the cube, we must simply multiply the area of one.
Now you only tell me what is the shape of each face of the cube? Square. How many faces the cube has? The best example for this solid is the plane what you use for that one. It has 6 faces. Each face is in the shape of a square. What is the formula to find area of a square? Side into side. If I represent any one of the side by small letter A, side into side is A into A square. As you said, how many faces you have here? 6. Then how to find the total surface area? I should add all the areas of the 6 faces. So how much it will become now? You see that?
6 by 6.
Total
As all the 6 faces are identical.
6A square. You will get 6A square. Suppose now tell me what will be the formula to find the lateral surface area? Why you are not using 6A square? Lateral means we should exclude the top and the bottom. So when you exclude the top and the bottom, only 4 faces are left over. So we should find the sum of the areas of the four lateral faces. Then what will be the formula for lateral surface area of a cube? 4a square. So lateral surface area of a cube is
Lateral surface area of the cube can be calculated by adding the areas that form the lateral surfaces of the cube. The area of one face is a square, and we have four such faces that form the lateral surfaces of a cube. So, the lateral surface area of a cube is 4a square. To find out the amount of gift paper he needs, Rahul needs to calculate the total surface area.
right. So now let me take some problems here. Now tell me, if I write this shape of a solid like this, tell me what is the shape of this solid? Cuboid. So here this is called, see, this is called length. Okay, and this is called breadth. What do you call this? Breadth. And what about this now? Height. Okay. Now tell me, as you have already learnt now, how to find the lateral surface area of this solid cuboid. Just now we derived a formula. What is that formula? 2 times L plus B into H. So you can write H either in the beginning or at the end, it doesn't matter. Why? Because commutative property of multiplication, A into B is same as B into A. So area is always expressed in square units. So this is the formula used to find the lateral surface area of a cuboid. Now tell me what will be the total surface area. As I said, total surface area, you should include the area of all the 6 faces. Just now we have seen the derivation. 2 times, tell me, LB plus BH plus HL. So once again, area is expressed in square units. So this is the formula used to find the total surface area of a cuboid. As I said, suppose if this is kept open, let me take another example here. See, this is once again a cuboid. This is a cuboid. As usual, this is the length. This is the length. This is called the breadth. And this is the height. Now, suppose if this side is kept open, how to find the total surface area of this solid? And this is what I said. If this is kept open, you cannot apply this LSA, because when you apply LSA, the bottom will not come, which is already closed. If I apply TSA, it includes the top also. Then the top is kept open. So even by using LSA, we can calculate. We cannot calculate. Using TSA also, we cannot calculate. Then how to calculate the surface area of this solid now? Tell me how to calculate. Any idea? I explained already. What to be done? Yes, see, surface area of this solid is lateral surface area plus area of the bottom. What is the shape of the bottom? Rectangle. What is the formula to find area of the rectangle? L into B. So along with the LSA, 2 times L plus B into H plus L into B. See, this gives you the area of this solid. So whenever the situation comes like this, you should be able to apply the required formula. Then you substitute the length, breadth and height and you can calculate. In the same way, we have studied one more solid, which is called as, let me name this solid now, which I am going to write now. See, this is a solid. Just now we have studied. What is this solid called? Cube. See here, in case of this length, breadth and height, these three are not equal in case of cuboid. See, all the three are different. But when you talk about this solid, what is this solid called? What is this solid called? Cube. See, here the length, the breadth and the height, all the three dimensions will be equal. Length, breadth and height. This is the one more difference that you can notice between a cuboid and a cube. In cuboid, length, breadth and height are different, whereas in case of cube, length, breadth and height are same. Now, the front face is in the shape of a square. So the formula used to find the area of a square is given by a formula side into side a square. Now it has 6 faces. So what is the formula to find the total surface area now of a cube? Area of 6 squares here, 6a square units. Area is always expressed in square units. What about C? Instead of C we use LSA. Lateral surface area. We use curved surface area only when they do not have a flat smooth surface. These two solids are having a flat smooth surface, so we make use of the word lateral. So lateral surface area, excluding the top and the bottom. When you exclude the top and bottom, you are left out with only the 4 side faces. It is called as lateral surface area. Then it is given by a formula 4a square units. Oh. So now here also I will write another solid where the top will be kept open. Now come on, yourself make a formula. See, this is given by A, this is open, the top is kept open. Can I apply the LSA to find the area of the solid? No. Why? Because if I apply LSA, the bottom which is closed will not come into the roll there. Suppose if I use TSA formula to find the area of the solid, the top which has been kept open, that area will also be included. But here the solid what I have shown, I have given here, the top is open. So neither I can use TSA nor LSA. Then what should be done? A separate formula should be calculated. Tell me the formula to find the surface area of this solid based on what we have studied. Yes, surface area of this solid is of course LSA plus, tell me, area of the bottom, correct, area of the bottom. Now what is the formula to find LSA? It is here only 4a square plus a square. So a side into side. You can make it, you can add algebraic terms, like terms can be added, you can take it as 5a square and you can calculate. Okay, any doubts here? Okay, let us work out some of the problems based on this now. So, I read out the question. See, a plastic box 1.5 meter long. Long is also equivalent word to what? Length. So length is given 1.5 meter long. Then 1.25 meter wide. Wide means what is the equivalent word to the wide? Breadth. It is represented by the B, which is given by 1.25 meter. Then 65 centimeter deep. Deep means what? Height. So deep is given. H is 65 centimeter. Now you see here, these two measurements are in meters, but this is in centimeter. To go for the working, all the units should be of the same kind. Means either I should convert meter into centimeter or centimeter into meter. Let me convert this centimeter into meter. How many centimeter makes 1 meter? 100 centimeter. Correct. So means I should divide this by 100. Why? Because 1 meter is 100 centimeter. Now because of 2 zeros, when I divide 65 by 100, no need of division. If the denominator is in the powers of 10, depending upon the number of zeros, you can shift the decimal places. Now tell me what will happen the decimal form of this 65 by 100. Now already it is h is equal to 0.65. Now what is the unit? Meter. Now you see all the three are of the same units. I know L, I know B, I know H. Now let me see what has to be calculated. Now it is open at the top. Just now an example I took. Now I am reading the question. The question says because of 3 dimension definitely it is a cuboid and the question says the top has been kept open. Now I should find the area of the sheet required to prepare this box. Tell me what to be done. All of you think and tell me the answer now. What will be the formula here? LSA plus, correct? LSA plus area of the bottom, correct? Area of the base or bottom, anything you can write. What is the formula to find the LSA of a cuboid? 2h into L plus B plus, what is the formula to find area of the base? L into B. So you know the length, you know the breadth. So 2, h means it is given here 0.65. So 2 into 0.65 into L is 1.5 plus B is 1.25 plus L into B 1.5 into 1.25. So when you simplify this, you will get the solution. Come on, get it done now in our book. And tell me what is the answer. You multiply 2 into 0.65 and tell me what is the multiplication. Okay, see here only you can do, children. See here, 2 5s are 10, 1 carry, 2 6 are 12 plus 1 13. After 2 there is a decimal point, 1.30 you will get. And here 1.5 plus 1.25, you can go for the working column there, 1.5, 1.25. Because of the second decimal place you put 0 and you are doing the addition. So 0 plus 5 is 5, 5 plus 2 7, 1 plus 1 2, 2.75, 2.75 and then 1.5 into 1.25. See, 1.25 into 1.5. Multiply now. 15 5s are 75, 7 carry. 15 2s are 30 plus 7, 37, 3 carry. 15 are 15 plus 3 is 18. 1, 2, 3 decimal places. So 1.875. 1.875. Now once again 1.30 should be multiplied by 2.75. 2.75 into 1.30. See, 0 multiplied by any number will give you 0. 3 5s are 15, 1 carry, 3 7s are 21 plus 1 22, 2 carry, 3 2s are 6 plus 2 8, 1 5s are 5, 1 7s are 1 2s are. See, all the multiplication and addition I have shown in the working column. So now 1 2 3 4, 1 2 3 4. So you will get 3.5750 plus 1.875. Do the addition now. So 0, 5 plus 5 10, 1 plus 7, 5 point. Show the addition if you want here. 5750, 1.8750, 0, 5.45. See, 5.45. So it can be taken as 5.45 meters square. So this is the metal sheet required to form that cuboid. Did you got the same answer? See, all the steps of working I have shown here in the working column. See here and here. This is the main part of the problem. So how to solve a question? First analyze what the data is given in the question. List down the values given. Take the suitable formula. Substitute the values in the respective places and simplify. So you go to the working column, either if you are not able to do it directly, go to the working column, multiply. Likewise, we are going to find the surface area for the cube also in the remaining problems in the next class.